Hello, everybody. This is Seung-Jin Kim from LG Electronics. I will talk about a very interesting topic, which is connected intelligence, which is related to the artificial intelligence, but combined with the wireless communication technology. I will skip this. You know, 6G will provide many different applications compared to the 4G. One of the interesting applications in 6G is remote medical applications. Many sensors will be used to help your health, your medicals. Like COVID-19, maybe the remote sense will help you to protect you from virus. So this is important in 6G. Currently, we have wearable devices like a watch or glasses, but in 6G time, 6G period, more wearable and sometimes implantable devices will come to you to help your health and your medicals. The next application in 6G is the glasses, the hologram AR glasses. The hologram will require higher data rate compared to the current, the video. So this will require high throughput communications. And at the same time, also, beyond autonomous vehicles, we expected drone will, provided by many companies, small drones, big drones, and even the drone taxis. So I saw the one article recently. Drone will replace ambulance. Ambulance in the traffic situation, especially in the city place, it's not easy, to find good hospitals. I mean, it will take a long time. But if you use a drone, then it will go directly. So it will reach very much quickly, just in few minutes sometimes. So this kind of many interesting applications will come through in 6G area. But as you know, in order to support this kind of applications, we need new technologies, including wireless communication and including new artificial intelligence techniques. But currently we use cloud-based AI. When you request your voice recognition in your phone will not respond to you. Actually, the response comes from the cloud server, not your phone. But if you request a lot, and many users request the voice recognition, then it will take a long time. And also, the latency is not short. If you want to communicate with your phone quickly, fastly, then you require more advanced AI techniques. One of the solutions is to include AI chip on your phone. Your phone will have AI functionality. Then your voice recognition will become quicker and faster, and even in some cases better in terms of latency. But your mobile usually have computational limitation, and also the data limitation will be problems. The solution for this case is to use some kind of connected technology. So this is called it as connected AI or connected intelligence or connected edge AI solutions. I will talk about these solutions. The standalone AI is, the artificial intelligence technology on your phone is the standalone AI. As I said, current solution relies on the cloud server. Every AI processing is performed at the cloud server. But in order to perform your AI process in your device should be evolved. So the AI technology is evolved a lot. Initial AI technique is expert system. So your logics, like in your modem. Modem is based on the logics. Many experts design your modem based on their experience and their knowledge, based on the many theoretics. The modem is developed. But later on, this kind of logics will be replaced by the machine learning. In machine learning, for example, this kind of decision tree will be designed automatically using the data by the training. Training data, this kind of decision tree or your modem will be developed automatically. But in this machine learning also has a non-automated area. The one of non-automated area is feature extraction. Feature cannot be extracted by the machine learning techniques. And the AI expert found that your features can be extracted by the neural network technology. So deep learning can extract the features. So feature part also be automated now. So firstly, the machine learning automated the logic design. Secondly, deep learning automated the feature extraction. How about the future? Still, the deep learning is not full automatic AI techniques. Deep learning requires more advanced, furthermore, automated techniques. So I will show you some examples. One of very important area is labeling. In order to train your data, you must provide labeled information based on the human experience. So, but in many cases, especially if you consider your phone, phone could be used training by themselves in the 6G area, 6G generation. It requires automatic labeling techniques. So one of the solutions is the reinforcement learning. As you can see in the AlphaGo, AlphaGo is trained how to play the Go, but it gives some kind of reward. When you win, your trial is success. When you lose, your trial is failed. So you don't need specific labeling in the reinforcement learning. So this reinforcement learning technique will help you to train your AI model without the direct labeling information. This is simple because it uses some kind of value functions. This value function will be updated based on current reward and the future predictions. So based on the aggregation of your reward, current reward, and the future reward, your value function is updated continuously. So this is fully automatic process in terms of labeling. Also, next one is the exploration techniques. The exploration is important in the reinforcement learning or many AI techniques. The new information can be captured by the explorations. So exploration is also important. And third one is automatic machine learning. This is very important, especially the AI is used for the standalone device. So I will explain those technologies briefly. The first one, as I said, reinforcement learning. Reinforcement learning can be replaced current labeling techniques. So we don't need direct labeling any longer if we can utilize this reinforcement learning very much nicely. So as I said, this will be updated based on the reward and the future prediction. So this is a new method to generate your labels automatically. So this is important standalone AI. And next one is exploration. As I said, for the reinforcement based training, exploration is important. You know, otherwise, if you don't explore, you cannot get further information. So exploration is important. But you know, if you explore too much, then your output will be randomized, because you explore here and there, then you cannot get a good result. But if you rely on too much exploitation, then you cannot also get the optimal result. So the trade-off between the exploration and the exploitation are important, especially when the AI will be used a standalone device. So this technique is important. One of the examples in the exploration area is the news article. We read news article nowadays using your phone, right? I'm reading my news in my phone. For the one news has many articles, many titles, right? But in the phone can provide only few titles in one page. So what kind of which topics could be shown in your phone is important, right? So initially we can show the topics randomly, right? Then later on, based on the exploration, based on the user response, we reorder the titles, articles. And then we've designed the optimal list. And then send back, show again, display again this optimal list, best result list. This is the example for the explorations. And in order to optimally explore the AI, there are several methods. One example is Thomson sampling. Thomson sampling has been developed by the medical researchers. He developed these techniques for the drug, drug optimization techniques. These guys give one drug to the patient and then check his response, his temperature, for example, his body's health status, and then he will change it based on this information. So he repeatedly, optimized the best drug candidates, and then he eventually find the best drug for him. This is exploration, and this has been, treated not the best solution up to now because of a huge computation complexity, and also at the same time, these techniques probabilistic-based technique. So this looks randomized solution. So this technique has not been treated the best solution yet up to now, but very much recently, it started to treat it as the best solution because it proved to achieve optimal performance. By the exploration, the optimal total regret should go, log likely patients. So the optimal patients, as you can see in here, should go the log way, but other solutions up to now is go the linearly. So recently, Thomson sampling become highly popular. The one of example in wireless communication area is to select the best frequency without moderate by the base stations. Initially, every probability to choose your frequency is random. So you can choose any frequency by yourself. Based on trials, as you can see here, this algorithm will provide you the best frequency for you automatically. But you need some time for the exploration period. But this algorithm, as I said, based on the optimality, it can trade off between exploration and exploitation, and it eventually find a best frequency for each device, almost likely when you use a moderated device. And many automation solutions for the machine learning and deep learning is required. One of solution is AI by AI technique. AI will learn not the data, like a supervised learning. AI will learn how to learn for the training. So this is kind of meta training techniques. So the one of these meta training techniques is train to guess the best initial models. Model is very complicated in AI always. How many layers, how many nodes, how kind of AI neural network architecture could be used. This is very difficult question. This question has been found by human expert up to now. But AI will replace this role, especially for the standalone AI. Otherwise, the fully automation is not possible. So this will be automated using these techniques. And also, it could utilize the data previously he has trained. Human, for example, can learn new information based on his previous knowledge. It can help you for your learn to be efficient and or more effective. So based on previous knowledge, you can improve your learning capabilities. So this is second method for the meta learning. And also many current deep learning techniques are designed based on the mathematics. Mathematics could be a good solution. The previous formulations. But this cannot guarantee the optimality. So these kind of algorithms could be also trained based on the data and experience. So this is a third method for the meta learning. So I wanted to say that the current deep learning should be optimized, should be upgraded to be more automatic ways. This is important. This is by doing that, our communication system could be replaced by AI submodules, not the logics. Logics is good, but it's static, right? So it should be updated by the long-time development. But if it can be replaced by the AI module, it can be automatically optimized for the new environment and for the new data and for new cases. So the neural net will replace current logic-based, modern functionalities. And then if you add up more automatic way, more automatic deep learning techniques, these neural networks can be trained automatically, right? So if your phone goes to some new environment, this will be trained automatically to optimize new environment. So this will make you communication more efficient and more optimized way. So the first one can be implemented by deep learning technique, but in order to implement the second one, you need to have advanced AI techniques in order to do some adaptation in your neural net-based or autoencoder communication systems. Now I will talk about connected edge AI. As I said, the standalone AI has a big limitation. First one is computational limitation. So the computational capability in your device is very limited. So by the use of split AI techniques, the part of your computation could be loaded to the base station of the cloud server. This is one of the solutions. This is called as split inference, split computing. And the second one is the pattern learning. Your data in your phone can be shared by other users, but not data by the sharing of your local model. you can get, or the global model can be developed without actual sharing of your data. So this is the highly privacy guaranteed the learning solutions. So the federated learning is important. In the split learning case, there are several situations. As I said, the current solution relies on the AI on the server, right? In the first image. And the second one is the model can be downloaded to your phone, and your phone can act your voice recognition. So this is good, but this has some disadvantage, especially the computational load. So secondly, this computation can be shared by the server or edge server or the neighborhood. So this will reduce the computational cost in your phone. But the latency will be increased. So there should be some trade-off between the latency and computational cost. So this solution is great if once we can trade off between the latency and computational cost. And then, interesting solution is sharing your computational cost from your phone and then edge server and the cloud server. The edge server could be a base station or somewhere near between the base station and your cloud server. So this edge server will participate computational processing for the AI. Then imagine that this will provide a new business. Currently, our 4G or 3G business highly rely on data service. But here, as you can see here, they will service AI from now and on. From the 5G and 6G, period, generation. So this will be interesting, topic. And the federated learning, as I explained, without sharing actual your data, you can train, the model, global model, almost likely you share your data by, sending your local model to the server. Server will collect your model, and the solution is easy. You just aggregate the model using the summation. So they will generate the global model and then feed back to the users. Then the user can use global models. This has been applied in many applications already. For example, your keyboard typing, your keyboard errors will be collected, not just from you, but from everybody, not by your real data, just the model. Then that kind of functionality is greatly improved. But this has been applied only wired solution. In wired solution, the bandwidth or frequency or the resource are not that important, right? We should consider resource efficiency in wireless communications. So we propose compressed federated learning in 3GPP. We provided as one use case of federated learning, the AI service in 3GPP. So this is compressed federated learning. This is something new, something advanced, because it considers resource efficiency. So we send the model, local model, to the server. We use compression. It is not just MPEG-like compression techniques. It is based on model compression. So it can reduce the computational costs. For example, 13 times it can reduce computational costs if you use VGG networks, at the maximum. Because it can send back not the local model directly, but it will send back the compressed models. So this is some kind of cost comparison. So For example, we consider VGG networks. VGG networks requires, when we calculated the computational cost, it requires 11 gigabps. But once you use original path rate learning, it can require 13 times higher, resource requirement. For example, 143 gigabps. But this is maximum resource efficiency. Real resource efficiency will be relied on wireless communication environment. However, as I said, in order to use the AI techniques in the wired solution or internet or the standalone AI, we should consider wireless impact or wireless environment. So one of the examples could be the compressed learning. So my summary here is standalone AI, edge AI is become popular because our device will have AI capability using AI chips or techniques. But in order to improve standalone AI, we need some connected intelligence techniques. So one of the solutions, especially for the mobile environment, is compressed path learning. This is just one example. Yeah. But many techniques, I guess, should be developed and should be proposed. Thank you.
Thank you, Dr. Kim, for the valuable presentation. So if you have any questions, please let me know. Any questions? So how about broadcasting? No questions here? Yeah, thank you, Dr. Kim. And let's move to the next presentation. So next presentation will be delivered by Satoshi Nagata, Dr. Satoshi Nagata from NTT Docomo. He's going to make a presentation about 5G standardization and NTT Docomo's activity. So actually this presentation will be delivered by online presentation. So we have video for the presentation, and then we're going to play the video in this screen. So, ready? Not yet? Okay. So let's wait some more time. We need some more time. That's it? Yeah, we are ready. So let's start the presentation.
My name is Satoshi Nagata, NTT Docomo Japan. Today, I'd like to present 5G standardization and NTT Docomo activity. Evolution of wireless access technology, as we can in this slide, steady evolution toward higher capacity and data rate is existing. And evolution occurs every 10 years. For the 5G use case, 3 use cases are existed, which are enhanced mobile broadband, eMBB, massive machine type communication, MMTC, ultra reliable and low latency communications, URLLC. As we can in the left hand side, 3 use case categories are considered. For example, enhanced mobile broadband case, gigabyte service in a second, as an example. In machine type communications, smart cities are considered. In ultra reliable and low latency communications, industrial automation, mission critical application, self-driving car are listed as an example. This slide shows the 5G requirements. For example, enhanced mobile broadband case, 20 Gbps for downlink and 10 Gbps for uplink for the peak data rate, and 3 times higher than the IMD advanced for cell spectral efficiency, area traffic capacity, user experience data rate, and 5% user spectrum efficiency. In the ultra-reliable and low-latency communications, 0.5 millisecond both for downlink and uplink. As a U-plane data latency and also reliability requirements is targeted. For the massive machine type communication, coverage, UE, terminal, battery life, connection density requirements are also targeted. This slide shows our company's views, for example, for 5G use cases and the creation of ecosystem transcending industries. Left-hand side shows the advanced mobile broadband use cases, for example, VR, AR, free viewpoint image, high sensor presence, and highly condensed traffic area such as stadium, and high vision image broadcasting, including uplink. Right-hand side shows the IoT-related use cases. For example, in the massive connectivity case, smart city, smart home, smart wearable, smart manufacturing are considered. For the ultra high reliability and low latency cases, drone control, tactile communication, telesurgery are listed as an example. In addition to that, thanks to the 5G, we can expect the creation of the new business model ecosystem transcending industries such as broadcasting, automotive, train, medical healthcare, agriculture, and manufacturing industry. This slide shows the time schedule for 5G. From 2020 and around, 5G commercial launch has already occurred all over the world, and also in Japan, 5G commercial launch has already started. In the 3GPP, Release 15 is the first specification for 5G, and both non-standalone and standalone specifications are specified. Now, 3GPP is discussing the Release 17 technique. This slide shows the 5G wireless access measure technology, especially for focusing on the new radio access technology, naming new radio, NR. The first point is a wider frequency range. In the NR new radio, from a few hundred megahertz to 100 gigahertz is targeted as a frequency range. And in these 15, below 52.6 gigahertz is targeted for the first specification. Second point is wider bandwidth. In NR, maximum 400 megahertz is supported as a one carrier. It means compared to the LTE, Release 14, 20 times larger carrier is already supported in NR. Third point is a scalable numerology. It means that changing the numerology, subcarrier spacing, depending on the carrier frequency, and also target services. For example, wider subcarrier spacing and the short latency can be considered as use cases of the higher frequency and wider bandwidth and low latency cases. For the new channel coding, LDPC channel coding for data channel and polar channel coding for control channel is already supported as a new coding schemes. In addition to that, in 5G, many antenna elements, especially for focusing on the higher frequency, is supported. There are multiple names of these kind of techniques. One example is a massive MIMO. Thanks to the massive MIMO, coverage extension by beamforming, capacity increase by multiplexing of multiple terminals, UEs, and beam management depending on the UE mobility is considered. This slide shows the technique to shorten the latency. The short TTI, transmission time interval, is one of the technology by changing the transmission time interval depending on the carrier frequency and target services. Another scheme is a fast retransmission scheme aimed at fast HARCAC hybrid ARQ. From this slide, I'd like to show our company, NTT Docomo, views focusing on the next generation, such as 5G evolution and 6G. As I said in the beginning, every 10 years, generation was changed. On top of that, every 10, 20 years, creating new value for markets existed, we feel. For example, in the first generation and the second generation, 1G, 2G, around 1980 and 1990, the first wave is occurred, thanks to the dissemination of mobile phones. Next one is a second wave, around 2000 and 2010 by 3G and 4G, due to the mobile multimedia. From now, around 2020, the third wave is now coming. In the third wave, around 2020 and 2030, resolution of social issues and human-centered value creations are needed, we feel, and new business value is expected. This slide shows our investigation result based on the 5G real issues. For example, 5G is the first generation using millimeter wave, such as 20 GHz or 30 GHz. This kind of the explanation of the high frequency band is the first time and not optimum yet, we feel. It means in the near future and future, these kind of the higher frequency coverage mobility improvements are needed to enhance the 5G. And also, high interest from the industries existed, and uplink performance enhancement on high requirement and main divergent requirement existed from the many industries. Considering these kind of the real issues, we need to consider how to enhance the 5G for the future. This slide shows the cyber-physical fusion for 5G evolution. Cyber-physical fusion is a forecast of future and discover new knowledge we feel. By radio communication in the cyber-physical fusion corresponds to the role of the nervous system that transmits information between the brain and each organ, such as eyes and limbs. For example, from the physical space, turn human things and events into the information and accumulate data to the cyberspace. From the cyberspace, forecast the future and discover knowledge based on the data analysis to turn data into value. And actuation is needed from the cyberspace to the physical space by doing the feedback of value to the physical world. This slide shows the future world view for 5-6C. First one is solving social problems, such as telework, remote control, telemedicine, distance education, autonomous operation of various equipment, including cars. Second one is a communication between humans and things, such as wearable devices, including XR, VR, AR, MR devices, and high-definition images and holograms exceeding 8K, and new 5-sense communications, including tactile sense. Third one is the expansion of communication environment, such as high-rise buildings, drones, flying cars, airplanes, space business. Last fourth one is the sophistication of cyber-physical fusion, such as large amount of information between cyberspace and physical space without delay and tighter cooperation between both spaces. This slide showed our company views for the requirements of the 6C wireless technology. Please note that the 6C research is in the beginning phase, so we feel the necessity to enhance this kind of the requirement based on the discussion in the future. For example, in the 6C requirement point of view, extreme high data rate capacity, such as over 100 Gbps peak data rate, and extreme coverage, such as gigabps coverage everywhere, and new coverage areas, such as sky, sea space, and extremely low energy and cost, such as affordable millimeter wave terahertz network and devices free from the battery charging. Now, the next one is extreme low latency, for example, end-to-end below 1 millisecond, and extreme high reliability, and extreme massive connectivity. From the technological study areas, we feel that no single representative technology is occurred around 4G, such as OFDM, millimeter wave, and massive MIMO. This kind of trend is also occurred in the 6C. It means that 6C will be a combination of new technology and enhancements. This slide shows a variety of technical components for 5G evolution and 6C, such as new network deployments, non-terrestrial network, frequency extension controls, exploiting a higher frequency and migration lower spectrum, new radio access technology, further enhanced massive MIMO, URLCC, and non-public network, and AI for everywhere in the mobile network, such as including integration of non-cellular technology, and new areas driven by unknown use cases. As I said before, these kind of the new generation research is in the beginning phase. We are happy to continuous investigation and research of the 5G evolution 6C. Thank you.
So this is the end of the presentation. So if you have any questions, please let me know. Any questions? So any questions in online? No? No. So then let's move to our next presentation. So next presentation will be delivered by Anders Johansson from Ericsson LG. So he's going to talk about Internet of Sensors source enabling industry and society transformation. So please welcome Johansson. So we need some time for the preparation.
That's right. Okay, thank you.
So please welcome Mr. Anders Johansson. Thank you.
Did I get some? Sorry, did I get something for this? Thank you. So up and down. So thank you very much. I'm super glad to be here. Anders Johansson, I'm heading R&D at Ericsson LG, also working with 5G and 6G software development, having persons here in Korea and in Shanghai, and some persons in Sweden working with VCU for Cloud RAN. See if we get the point. So the content I will cover today. Internet of Sensors, dealing with uncertainty, perspective, how that matters, and also the wide spectrum of sensing. We'll give some slides here on Internet of Thoughts, new elements for telecommunication, machine learning, and BCI. Speak a little bit about mind-controlled drone or robot or exoskeletons. And as a last bullet, I will speak about industry and society transformation with Industry 4.0 part and finish off with some consumer trends for 2030. So this is a bus that we have in Kista in Stockholm. Many companies have been involved in doing this. Here, my company is one of them. So we have a self-driving bus using cameras, using radars, and so on, and it drives passenger then from different areas in Kista. And important here is that when we have a self-driving bus, the number of sensors and how you share information in order to make correct judgments. So it's not only cameras or radars on the bus, but also building up information from the environment around there, and having a network that can share that information between the sensors is a key to make the right conclusions. So if we take the next slide. So, and when you have information from multiple sources, I mean, having a lot of data then take away the uncertainties. So by having looking in a multitude of distributed observations, you will end up with a normal distribution, and then with more data, the better the picture you will get here. So the multiple perspective provide trusts. If you have the more data you have, and the more perspectives and the more sensors you have, the better predictions you will be able to give here. And if we combine data from history and presence and share that, then you will be able to get the best, do the best conclusion. You have seen these pictures, I'm sure, many times. This is typically a picture where you throw in some object classification algorithm on this. And in this specific picture, with the right conclusion here, you will be able to say, yeah, I can drive in the green field here without hitting anyone. That will be an okay thing to do. Problem might occur then if you have a picture like this. Here you have information from one sensor, the camera, and with only this information, it might be, you might draw the wrong conclusion. So having information from multiple sensors is needed in this type of situations. And having a network sharing information from those sensors is a key for that. Also, the multiple sensors, if you see a picture like this, you always, or you yourself, you make, with your preconception, you make conclusions how this one looks on the back. And with just one set of sensors, you will assume that it looks on the back as it does on the front. But having a multitude of sensors will enable you to see the back of things as well. There is many ways you can have sensors. You can look on the microwave frequency, the FEAR, the MIR, the NIR, the RGB, ultraviolet, and so on. And with the multiple sensors here, you can understand much better on the objects you're looking into. So if we transform this then to Internet of Thoughts here, this is a statement from our founder, Lars Magnus Eriksson. Communication is a basic human need. Today, what we have is that we're using, the screen as and our typing on the screen as our interface. And the question is, this cannot be it. This cannot be the most optimal way of feeding information into or getting information back. So as we see, it's very much a gap filler. The interface we have today with screens, typing and texting, it's looking forward here, it's regarded as a gap filler. There is different ways to feed in information. We all use Siri or similar tools to orally ask for things. And if you look on Google machine learning, already 2017, we were able with Google to more accurate than a human can understand the words, and so the word accuracy is actually better now in Google than it is if you speak with a human. Problem is you just don't go around and speak with Siri in public. So what else can we do? If we imagine a world where all the knowledge and fun and utilities of today's smartphone were instant accessible and completely hands-free, a decade from now, the ability to type directly from our brains may be accepted as a given. Not long ago, they sounded as science fictions, but now it feels within plausible reach. And now I'll show some example on this. You have from Facebook, you have this BCI interface, and you can read the article here from 2019 where they used this BCI helmet to get input. You have already in 2016 in Florida, they had the world first brain-controlled drone race. So no hands were used, they only controlled the drones with the brain. We have also, if you go back, we have also now from last year, in June, the first ever successfully mind-controlled robotic arms without brain implants. So they have sensors in the arms, and that control then the robotic device with the mind alone. And of course this heavily benefit the lives of paralyzed patients and with movement disorders. So this is an important step in a non-invasive brain-computer interface, a technology that someday may become pervasive assistant technology aiding everyone. We have this exoskeleton you might have read about. It's from Japan, and where they use an exoskeleton on people who are paralyzed, and with sensors in the skeleton. Also, they use the bioelectric signals from the brain, and that reinforce and recovery of the brain muscle signals. So it helps people who have been paralyzed or have hurt their spine, etc., to be able to walk or move again. And it also helps rebuilds the nerve signals from the brain to the muscles. So just having this, strengthening this, also make them recover in a faster and faster way. So Internet of Thoughts, or food for thoughts. If we in 2030 control things more with our brains, this the thing we do now with typing on the screens might be a thing of the past. Having non-intrusive BCI available of mass markets, quick control loops. Think of combining this with XR, and this is about reading things then from the brain. The opposite here, or the opposite here, maybe it's a bit far-fetched, but if we can read things from the brain, can't we then in the later stage write things to the brain? If we are able to read signals from the brain to steer things, could we then do it the opposite? I think that's more of a thought for the future. The last area, Industry 4.0. You have had 4 different industrial revolutions. The first one, as you all know, was mechanization, steam and water. Second one was mass production and electrification. The third one that happened was with electronics and IT and repetitive automation. What's happening now with the fourth one is CPS, IoT, adaptive cognitive and autonomous sensor and actuators controlled by AI, control system, etc. This area is judged in 2025 to have, or this market is judged to in 2025 have a value of $3 trillion. And we heard some of the previous speakers speaking about sensors and how big part that would be on the communication part. Some estimates here is that 37% of all the IoT part will be from Industry 4.0. So we're going from an industry. Oh, sorry, one too many. So we're going from a. No, we're going from a. We're going. No, I'm going too quick here. Sorry. Go back. Okay. So we're going to a more tailored or automated supply, where we have inventory management, track and trace, shop floor environment, activity monitoring, real-time insight and decisions, perceptive robots, adaptive productions, self-healing machines, tailored products, AGVs, enabled flows, reconfigurable lines, collaborative machines, safety and responsiveness. Typical number of sensors on one such machine when we are doing now this Industry 4.0 factories, and it's a lot of these requests now. Many companies started off in Germany, doing a lot there, but there is also many things happening in many countries, including here in Korea. But it can be up to 100 sensors in one single machine here. You will then have full monitoring and control, adaptive flows, aggregated and seamless experience, and a web of activities with supply chain, assembly, product usage, both centralized and localized production. All assets and machines, activities of Industry 4.0 will be connected and embedded with sensors and actuators. The data will be controlled, will be used in processes. And we go from a mission critical to a very relaxed requirements with massive amounts of data and control commands to be processed through a global inter-enterprise level. And the networking part will be key to make this happen. My last slide, just speaking about some consumer trends. As we started off with, or had in the middle here, the brain becoming more of the user interface. Sound like me, one can transform voices to sound like anyone I want, any flavor you want, digital aroma, total touch. We will see more and more possibly on getting the touch experience, merged reality, verified as real. In the world of fake news, we have this checks of statements that is done, it can be done in real time. The security part or the privacy part will be a growing thing. Connected sustainability, using this for sustainability, I think will happen. And then different kind of sensational services. Some of them are a bit more far-fetched, some of them quite sure will happen. So that was my last slide. It's a bit of higher level description on the area and what it can be used to. So I think I stop by that.
Thank you for your presentation, Mr. Johansson. So if you have any questions, please let me know. Any questions? Yes, please.
Yes, hang on a second, we get the microphone to you.
Thank you for your interesting copy of the presentation, and I have some question about the brain communication, very interesting.
Yeah.
And I just wondering how can the brain communication be realized, like those kinds of communication can be provided by communication operator like SK Telecom or KT, or they just can be standardized by some kinds of standard community like Bluetooth. How can they be realized? What's your opinion?
So the question is that how can the brain communication can be realized in current existing standards?
Yeah.
Okay, that's the main question.
Yeah, no, good question. So also for the people on YouTube here, so the question was how can we use networking or communication combined to the sensors for the brain control interface here, or the BCI. I think in many of these cases there will be a lot of sensors. You saw in the skeletons or in many other areas, it's a lot of sensors in that, and those sensors needs to speak with each other. So it's not only one sensor alone; it's the communication between many sensors that enables us to make the right conclusions or the right decisions. And there, I think communication will and the networking will play a very important role here. So we will need to gather data from many of these IoT devices and communicate that, and having them speaking with each other, and then draw the conclusion. So I think then exactly what technology we use and how it will be used. In some of these cases it's Bluetooth. In some of other cases there is other setups that they communicate. I think there will be. If you go back then to 5G and 6G, what we have here is that you have much lower latency and much quicker speed, and taking these real-time decisions in a very fast way will be very important. We see that if you were in the Barcelona Mobile World Congress, you see that we're steering cars from distant locations on a racer track. And the latency is key there. I mean, you have to have very low latency, very high speed, and that's what you get more with 5G. You will get even more with 6G. So I think that together with the communication between the sensors will be key to make this happen. And we are in the center of this. The communication part will be key to make this happen. And there, I think all operators and companies, vendors in this area will have opportunities. And also looking on just the mere numbers of sensors that we speak about. $3 trillion is the market 2025, only in Industry 4.0. It's a tremendous market, and 37% of the sensors. So I think this is a huge opportunity for everyone in this space. Thank you. Really good question. Thank you. Good. Any more questions?
Thank you, sir, for your presentation. My question is on number 4. The hot trend for 2030, you said that digital aroma. So my question is, how is digital aroma an expected hot consumer trend in 2030?
Yeah.
And can you suggest to us the technology candidates to address this?
Yeah, so your question was,
digital aroma as a hot trend for 2030. What is digital aroma and what are the technology candidates to meet that?
So actually the question is that the digital aroma, number 4, so how the technology can be realized, right?
Yeah, so repeating on the YouTube viewer, so the question was on the 10 hot consumer trends for 2030. How will the technology play into this, and where will the technology come into this consumer trends? I think in the brain is the user interface. We answered a little bit in the previous question. So there will be a lot of sensors from the brain, and that will be used there. Then I think in many of these, like such as connected sustainability, same thing there. You have a number of connected sensors or devices where you need to share the data and the information in order to make sustainable decisions. It could be, how you're shipping things, how you are taking decisions on how to maybe manufacturing things and so on with less waste, etc. So I think communication can come into many of these areas. How the communication come in and how the sensors come in, I think that is for us to invent. I think we need to think of what areas would we benefit of having a sensor. And all those areas that we could benefit of having a sensor, I think we would. I spoke with my colleague over lunch here. He's going to play golf now on Saturday, first golf round. He has been practicing golf. And you do all of this kind of analysis on where you play golf, and in analyzing the golf swing, analyzing how you hit the ball, you analyze how the ball is spinning, etc. Sensors everywhere. Maybe sensors in the tip of the golf club. Maybe sensors on you as a person. So all areas where we think we can have a benefit of knowing more of what we do and how we can improve. I think you will have sensors. I think figuring that out. I think we have a lot of young students here in the room. I think this is a lot for you to figure out. Come up with ideas. Where will we benefit of having sensors? It's a great opportunity. I think we will see sensors in areas we could not think of today. If you go ahead 5-6 years. So I don't have a full answer on this. I think in some areas I know. In some areas I think we need to figure it out where it would make sense.
Thank you. Thank you for your answer.
Yeah.
So you have more questions? Do you have any questions in online? No? So thank you for your presentation, Mr. Johansson. So thank you.
Thank you.
So actually, This presentation was our last presentation, so this is the end of the industry session. So thank you for your attention and participation in this session. Thank you.